Spiral galaxies seem to dance in space. The disk of this galaxy has twisted due to gravitational interactions. The bright center of spiral galaxies usually reveals the existence of a supermassive black hole, like this one photographed in our galaxy. This galaxy is 70 million light years away. Will a descendant of man ever see it? What will man be like a billion years from now, when he could, in principle, reach these colliding galaxies? That's not an alien rocket. It's two galaxies in a direct collision. New stars are forming at the contact zone. See that long red streak? It's the trail left by a galaxy and its movement, because some of the atoms from the moving galaxy are stopped by the intergalactic medium. Everything we see in this patch of the sky are galaxies located billions of light years away. To get there, humanity would have to survive for billions of years. Will it succeed? Will it reach those galaxies, the antennas forming two colliding spirals? A. Plunger, descendant of man, heads toward this galaxy's center over billions of years. What will he find on the star at the bottom left of this galaxy, the one wrapped in 9 rings like Babaducha? What's the point of wonders in the starry sky if no one sees them? They are almost certain that somewhere in this spiral galaxy, early life is hiding. Here, the young stars on the edge emit ultraviolet radiation, which excites and illuminates the surrounding gas. Life could be in danger there. Let's find our companions. I wonder if intelligent beings like us exist in this galaxy, surrounded by red gas filaments. Or maybe the truly intelligent ones in this group of 3 galaxies interacting gravitationally don't consider us intelligent at all. Maybe, after all, we'll find our brothers here. Or here. They have to be somewhere, don't you think? Here, thousands of galaxies are being sold that are billions of light years away. It took light billions of years to reach us. They are the cosmic fossils of the early universe. You can hardly see a few small red galaxies among them. They are small because they are very far away, and their light is redshifted due to the expansion of the universe. We see them in their childhood. The bright center of this galaxy hosts a very powerful supermassive black hole. The spiral arms of the galaxy are sprinkled with young stars visible through their bright blue light. In contrast, the redder central part is mainly old stars. The gas escaping here blocks 90% of X-rays from the galaxy's center. In the upper left is a galaxy whose supermassive black hole emits a relativistic jet of electrons across vast distances. A young galaxy is a nursery of stars. The massive elliptical galaxy M87 is 50 million light years away. Its galactic core has a blue jet that reveals something. A supermassive black hole, photographed here for the first time. It was known that there was one there. Here are the updated results in the narrated physics, possibly from before the black hole was photographed. The Sombrero galaxy is a bright bulge surrounded by dust lanes. Spiral galaxies generally contain many billions of stars. They are millions of light years away. They stretch for hundreds of thousands of light years in diameter. In their spiral arms, new stars are born from clouds of gas and dust. This is how the Sombrero galaxy looks through an amateur telescope. Sometimes galaxies look like ribbons. Others have strange shapes, especially when they merge, and after a while, they start to look alike. There are hundreds of billions of galaxies in the observable universe. Since then and up to today, colonies of lost moons, as Eminescu says, being islands of chaos. On unknown paths and in luminous swarms springing from infinity, they are drawn into life by an endless longing. What is this supernova like? That's how I was, the Andromeda galaxy, through my camera. This is how it looks with a professional telescope. The Orion Nebula, with the same camera of mine, photographed by me. Now, photographed by an amateur with good equipment. And photographed by the Hubble Space Telescope. The M51 galaxy, you can see it with a small telescope. But hey, if you have Hubble, that's a whole different ball game. The Einstein ring forms when images of galaxies are distorted into arcs of a circle. The light coming from the distant galaxy passes through a region where space is curved, and Asa bends as well. When there are hundreds of galaxies bending space, the cosmos becomes a painting of arcs stretching across billions of light years. Moreover, the galaxies are colored in hundreds of shades, depending on their nature and their distance from us. The smaller galaxies are farther away and appear slightly reddish due to the redshift of their light. Here, a small red dot from the image is magnified. It is the most distant galaxy, over 13.4 billion years away, light from afar. Some galaxies interact, forming clusters spanning hundreds of thousands of light years in their gravitational dance. Others channel hydrogen gas along well-defined lines into their central bar, so that young stars can then feed on it. On the cosmic canvas, some galaxies position themselves sideways, as if trying to hide their central treasure. This is what the magnetic field in the center of our galaxy looks like. It pushes some of the ionized matter away from the center, which would otherwise fall toward the supermassive black hole there. Don't forget to give a like, leave a comment, and share this video. Thank you very much. Don't forget to like, leave a comment, and share the material on social networks. Thank you very much. Here is an active spiral galaxy, the second brightest among the known Seyfert-type galaxies. Oh, it's such a perfect day. I'm glad I spent it with you. Oh, it's such a perfect day. You just keep me hanging on. I would spend an hour looking at every star in this galaxy. What wonders are out there? It looks like a cosmic flower, but it's actually two galaxies interacting gravitationally and being deformed. Here, the yellow color reveals that these galaxies are old. I wonder if the aliens there are getting ready to leave. You look at the sky and you see the theory of relativity. The left part is the distorted image of a distant galaxy. The distortion of the image is due to the curvature of space, which makes the light travel as if through a lens. At the ring's center is a massive cosmic object that distorts space, typically a galaxy or group of galaxies. At the ring's edge, you can often see a distorted object, usually another galaxy. This is behind the central object, visible only at the ring's edge. It's as if the universe is smiling here. The galaxies seem to rest quietly in space, showing off their billions of stars. If we visited each of its stars for just 1 second, we would need hundreds of lifetimes. Sometimes, dark matter brings galaxies together. We would need hundreds of thousands of lifetimes just to look at each star here for 1 second. When galaxies get too close, they interact gravitationally and form bridges of stars. Here, a quartet of galaxies performs a cosmic dance, inviting space tourists. But let's not fool ourselves. It's almost 100 million light years away, and we can only admire their strange and distant beauty. The dance of these two galaxies with arms 50,000 light-years long leaves no room for doubt. Gravity dominates the interactions between stars and cosmic dust, causing the stars to arrange themselves into specific shapes, like these arms in an elliptical galaxy. But what gives light to each galaxy are its stars. Here are hundreds of billions of stars, cosmic furnaces that shine as they fuse their cores. The same process that forms the heavy atoms in our bodies. Atoms released when the star explodes. We are literally stardust. Sometimes I wonder if the human biological mind can grasp the billions of stars in a single galaxy. We are billions of people and we don't know them, so how could we know so many stars? Could it be that artificial intelligence, maybe that of quantum computers, will be the one to finally understand the billions of unknown lights that dwell here?